This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
Hey everybody, welcome to another Ruby Rogues podcast. I am David Kimura, and today on our panel we have Eric Berry.
Hey there.
And we have a very special guest, Sam Aaron.
Hi, how's it going?
So Sam, tell us a bit about yourself and some of the things that you're doing.
That's a good question. I don't really know how to describe it in a very simple way. I do lots of different things. I try and challenge programming and take it to new directions. And of late, I've been trying my best to figure out how I can be the most expressive person I can with code and how to help other people do the same kind of thing. And the medium I'm using at the moment is to use code to make music. So I've written a system that allows people to do the same because it's not just good enough for me to be able to do cool stuff. I want to be able to share it with the world. And hopefully we can start to all have a conversation about making music with code.
Awesome. So you taking the code as art to a literal sense.
Yeah, well, I think that code is just a medium, like writing or painting or dancing. And you can use both of those things, all those things for very variety of different things, not just artistic things. They're really just expression. So you can use writing for legal statements, but you can also use it for writing poems. I think that the fact we see code as a very business-oriented thing typically, I think it's a limited view. And I think we should just see it as we see writing, and we can use it to express many different things.
That's really cool. So tell us a bit about Sonic Pi, the project that you have developed to generate music from code.
Yeah, I mean, it's how do you want me to start? Like how I started on the project, what I'm trying to do, where I'm going. I mean, it's a very simple program. It's an app that you can run on your Mac or on Windows, or if you don't have either of those things, and maybe you can't even afford a laptop or a computer, it runs on a Raspberry Pi computer as well. It's installed by default, which is why it has the name Pi, because it was originally written for the Raspberry Pi. And it was written originally as a response to the UK launching a new computer science curriculum in schools. And so the challenge was, how do we get kids engaged in programming? And so Sonic Pi was my response to that question. And it's turned into, since then, from sort of a tool for experimenting in whether or not music could engage children in programming to a fully fledged musical instrument in its own right. It's really taken a whole life direction of its own. It's exciting.
That's really cool. And was this developed by a team of people, or was it in conjunction with anyone else?
So the majority of the work is myself, although it is an open source project, and we've had very many fabulous contributors which have, over the years, who have helped out in a variety of different ways. But there's no real team as such. The only sort of full-time developers me, myself. But I have worked with fabulous other people, as I said.
Awesome. And so what's the history and the motivation? You said that you wanted to bring schools or bring this into a more educational environment, but why music? Why not something like a graphical or drawing library where you can do something visual? What made you choose the audio style?
Well, that's a good question. Many years ago, I had a tragedy in the family, and I was really sort of struggling mentally, dealing with this issue. And one of the ways I helped myself was to pick up a book on processing, the sort of drawing tool that's based on Java. It's a fabulous tool. But the weirdo I am myself, I looked at this system and I thought, it's based on the JVM. I'm really interested in this Clojure language. I'm going to see if I can work with processing and Clojure. And lo and behold, someone had already made a very early prototype of a combination of these things. So I spent a lot of time implementing that and then building it out and renamed it something called Quill, which has really sort of taken its own life. And so I started off in many ways doing visual things. And then obviously audio complements that. And so I was thinking about how could I make interesting sound as well as interesting visuals. And so again, I was exploring a variety of different ways of doing that. And when I'd seen these visual systems, I either got the skeuomorphic systems, which try and model what an actual traditional music studio is. And if you don't have a huge background in how studios work, and for many years, they can be really daunting and difficult. And on the other hand, you've got these very visual tools for making music, which are boxes and lines. But when you see anything that's interesting, they're just far too complicated, too many lines, too many boxes, and it's just a whole spider's web mess of disaster that when we as programmers, we use abstraction, we use tools to manage this complexity. So it just made sense to me as a programmer that we should be using programming tools to do these things. And so I'm using programming tools to make visuals with processing and Quill and Clojure. Why not do the same with music? And of course, at that point, I discovered many, many live coding systems and music systems for doing exactly that. So it's just really sort of forging my own path and way through all those things.
That's really cool. So can you talk about the architecture of Sonic Pi? Because it is cross-platform, and while there are many cross-platform applications out there, one that comes to mind, Inkscape, it just doesn't really have that same flavor of a native application feel, or more so the interface of it. But Sonic Pi looks, really good playing with it here on a Mac OS. And, what was your inspiration behind the UI and its architecture?
So, as I mentioned before, I was playing with these sort of Clojure-based systems, Quill being the visual one. And then I started working on a system called Overtone with a friend called Jeff Rose. And we were working on these systems for a while. And so Sonic Pi came purely not for my own sort of artistic expression, but it came from a response from where I was working. And someone said, we've got a small bit of money to spend on somebody who can build possibly a prototype for teaching kids how to code. And so my initial thing was to try and get this Overtone, this Clojure environment running on the Raspberry Pi, because the goal was to make sure it can run on the Raspberry Pi. But it just took too long to boot because the JVM support was poor. And so it was obvious to me that I could take a lot of the ideas from Overtone and port them to the Raspberry Pi, but using a different language. And so Ruby was a natural choice for me because I used to be a professional Ruby programmer. And it has many of the niceties of a Lisp language, not all, but many. And so it was quite obvious to me how to build a very simple prototype. So a lot of the architecture was the original core, all the abstractions were taken directly from Overtone, this Clojure live coding system I've been working on for a number of years prior to that. And the way it works is you have a very sort of simple server. So there's a Ruby server which is talking over a network socket to something called SuperCollider. And SuperCollider is a fabulous open source synthesis engine that has two components. One is a language, which allows you to describe music and synthesizers. Another one is a server, which sort of is an engine which generates all the sound and manipulates all the audio streams. And so with Overtone, the idea was to try and see if I could replace the SuperCollider language with Clojure. And Sonic Pi was, again, a very simple, very much cut-down version, which was implemented in Ruby. And so the Ruby server would talk to SuperCollider. So you have a Ruby process talking over a network to SuperCollider, and then you needed some way for the user to control and manipulate the Ruby process. And so I created a very simple graphical user interface using Qt, and because I needed something that was really, really sort of fast and low memory footprint to run on the Raspberry Pi version 1. And so the Qt then talked to the Ruby server, which then talked to SuperCollider. So there were sort of three separate processes all talking over the network.
I want to give the listeners a little bit of an idea of what this sounds like, if that's okay. And I'm
sure.
Pretty amazing. So here's the sound, and let me know if you can't hear it, but here's the sound, which is literally 4 lines of code in Ruby. Can you tell us a little bit about what goes into making that sound work?
Of course, yeah. So the bottom layer is the maths used to generate the different audio waveforms which compose that sound clip. And so there's this mathematician Fourier. He discovered that any sound is really just a composition of different sine waves, the purest sort of sound wave you can create, at different frequencies, so high or low, and a different phase starting point, so whether it was at which point it started. And if you can combine them in the right ways, you can create any sound. So those bell sounds you heard were actually in that example. I think it's so either you could synthesize a bell sound, so there is a pretty bell synthesizer which uses the mathematics to generate these things, or you can play pre-recorded samples. So these are where the waveforms were in time at this time that some sound was produced. In the example you're showing, does it say the word sample in it somewhere?
It's haunted bells. It's the very first example.
So that's got a sample of a bell. So you can there is a bell synthesizer which I thought we were playing, which I was describing. But also you can record the sound of a bell with a microphone, and the audio file that's produced you can then use to play back. And so Sonic Pi has just one line of code to play any audio sound. But the cool thing is you can play the audio sound as it was recorded, and then you get sort of a one-to-one sort of mirror image. So it comes out of your speakers as it was produced. But of course, you can sort of middle and futz it as it's playing back. And so that all those different sounds are high and low sounds, which is the same sound stretched or shrunk. And if you stretch a sample, it takes longer to play back, just like if you sort of pull a slinky out, it's a longer object. But it also has this effect on the sound to make it sound lower. And if you squash a sample, of course, like you're squashing sort of jelly, it gets smaller. But of course, then that has the opposite effect. It makes the sound higher. So you can hear those bells are sounding higher and shorter and lower and longer as the rate of the sample is modified. So you then have a loop. So at this point, you have a way of triggering sound. You have a way of modifying the way that sound's played back. But then you need some sort of construct to then play it multiple times. So there's likely, and that thing is a live loop, which is a loop which spins around every half a second or a quarter of a second, and then triggers that sample again. But the rate will probably be a random value between some positive and negative values or high and low values. So that way, every time round, it's going to trigger the same sample, but stretch it or shrink it higher or lower, and it's going to sound different. And all the sounds are going to blend together. Does that roughly say? So
absolutely.
Let me play one more. Strokes, a way of playing a sound, and then a way of waiting the right amount of time between the sounds.
That's incredible. Cool. Let me play one more. And this is the example that you have called Acid Walk, and this is the kind of the biggest.
It's a bit more fancy, yeah.
It's a bit more fancy. So let's give it a listen. All right, so that's clearly very intricate, but I'm looking at the code, and it's still, 80 lines, 60 lines?
Yeah. I mean, you've got the bass drum going boom, boom, boom. That's just a loop with a line that says play the bass drum, wait for a bit, play it again, right? It's very simple. And the same with the ticking sound, tick, tick, tick. It's just which sound to play, the tick sound, and how long to wait before you play it again. And then the melody thing, that sounds complicated, but all it really is taking notes from a scale that other musicians have chosen and just designed. So basically, scales are just sort of palettes, in the same way you can have a color palette for your website. I want to just choose these grays or these greens, and you might choose a color palette. A scale is just a color palette for notes. And so it's a set of notes that you can just randomly pick from, which I'm doing, and then randomly wait a choice of times between playing the next note, and then it sort of creates this melody and rhythm just randomly for you, which can sound interesting. And then you're adding effects, so you're modifying the sound of the sound by adding some reverb or just some distortion or some echo or that kind of thing. Yeah.
That's really cool. And, honestly, most of that is way over my head. I'm not very musically inclined. But one thing I am curious, because the target platform was a Raspberry Pi, usually when I think of Raspberry Pi, I don't think of Ruby, I think of Python. So why did you choose Ruby over Python for developing the Sonic Pi engine?
Oh, that's a very good question. I mean, before I answer that question, I'd like to just challenge you on this idea that you're not musical. I hear it all the time, and it really frustrates me. I'm sure you believe it, but I think that maybe a fairer statement is that you're not a professional musician. Because I don't think that anybody in every human is musical to some degree. We can all hear a melody, we can all tap a rhythm, or we can all wave our arms around to the music. We don't have to be able to be professional skilled, but we all can all be a bit musical. And I think tools like Sonic Pi can help us to learn and express that a bit more. And I think that's this idea that you're not musical as a barrier, I think is a barrier to lots of other people. And maybe the listeners out there think, oh, yes, I don't feel very musical, but actually you really could be. And I remember listening to an interview with a lady, she was 100. And when they asked her lots of different questions about her life over the many years she was alive. And one of the questions they asked is, do you have any regrets? And she said, yes. And the chap said, well, what is your regret? And she said, well, when I was 80, if I had started to play the violin, I'd have been playing it for 20 years. So I think that this idea of not musical, I think is just as a mind barrier. It's not necessarily a real thing.
Yeah.
But anyway, so to answer your question, why did I choose Ruby over Python? Because I had an insanely ridiculous schedule to implement the first for the project, really. So my contract at the University of Cambridge was about to expire, so I was about to move back to being a professional programmer again. That was also the general trend. And then that was the same year the Raspberry Pi was released, and it was a staggering success and surprised everybody. And so at that point, they were pumping out this hardware. It was selling really well, but they didn't necessarily have the software which ran on that platform, which was going to be super exciting and engaging for kids. I mean, they've been working relentlessly since then to try and fix and change this. But at the time, there was very little education software that ran on the Raspberry Pi 1. And so there was a bit of money pushed around for a small project of 3 months was the duration. And I thought, when I signed up to this, so this is a good idea. Maybe I can take my overtone system and port it to the Raspberry Pi. Was my original thinking, not thinking about Ruby at all. My thinking was that the project was, in 3 months, build a prototype which may potentially have use in teaching children how to code. And I thought that was already quite a exciting and tough problem in 3 months. And when I sat for the first meeting, it turned out that I was absolutely wrong. That what they wanted was the implementation of the system that was complete in the 3 months, but also to find a teacher to go into a classroom to use the software to teach Sonic Pi, not Sonic Pi, to teach computer science for I think it was like 6 or 7 weeks, to evaluate that and to assess everything. So of course, then if you're doing all that evaluation in classrooms, you can't go in with no software. You have to have software. So the first version of Sonic Pi took me 2 weeks to build. It had to be the simplest possible thing. And then I iterated on the development. So every week I'd go into the classroom with a different version of the software and implement it on a week-by-week basis as I was working in the classroom. So because of the ridiculous tight schedule, I had to use a language I was very familiar with. And as I said before, I was a professional Ruby programmer. I really like the Ruby programming language. It's perfect for this. The lexical closure as a optional sort of do end to every method is a beautiful construct for writing languages like Sonic Pi that Python just doesn't really have. You can do it with a lot more syntax. And then also these are personal opinions, but I believe that the Ruby syntax is so much more lenient than the Python syntax. We can talk about the pros and cons from a professional perspective as programmers, but actually there's different pros and cons in an educational context. And I've observed that it's actually really nice to have a language where it tolerates mistakes much more than Python, which really does not tolerate any kind of mistake. In fact, it punishes you if you put things that you can't even see there with the white space stuff. So you have to get everything absolutely perfect. Whereas because Ruby has a bit more verbose syntax for the do ends, the system can actually help you and do the indentation and smarten and neaten the code for you automatically. And these are really nice things in an education situation that you'd have to fight against, because the amount of time you have in the classroom is so minimal. You want to spend as much as you can teaching the concepts, not trying to fight the tools.
I'm looking in the code right now, and I'm seeing that it looks like the application Sonic Pi is written both in Ruby, but you've also got some Erlang in there.
Oh, yeah.
Can you address that real quick? I'm just curious.
Yeah. So, I mean, you asked earlier about the architecture, and I talked about 3 components. So the GUI talked to the Ruby server, which sits a bit like Nginx or Apache, waiting for messages from in Ruby description about what to do musically, and then converts those to messages to SuperCollider to send to your sound card. Now, this was working really well. But then people kept saying I wanted to work with external synthesizers that were controlled by, say, MIDI, which is a protocol which was invented at the end of the 70s, early 80s, to connect keyboards together. So you could press the note on one keyboard and have it play on another keyboard if you put the right wire between them, this MIDI cable. And so I wanted to be able to trigger external synthesizers using this MIDI protocol. But it's not just enough to be able to say, I want to be able to send a message to the MIDI synthesizer. I need to be able to say, I want to send it at the right time. And so far, we haven't really spent any time talking about time, but Sonic Pi, I've spent so long building and designing the system for making it accurate in terms of time. It's crazy. I needed to be able to, so the way it works is that Ruby does not do the timing, because that would be nuts. Ruby just manages when things should happen at what time, and then sends those messages to SuperCollider ahead of when they should. So then SuperCollider is sort of really very optimized C++, and the bit that does all of the timing doesn't have any mallocs in it. It doesn't have any I/O. It's like super tight piece of code, a high priority thread. So you want to use that for the timing, not Ruby. And I wanted to have the same thing for MIDI. So I could imagine writing a Ruby program which had a function called MIDI, which sent a MIDI message out. And then I could use the Ruby sleep to wait some seconds and then send another MIDI out. But it's just a terrible approach, because you've got the Ruby GC kicking in now and then. And sleep just says sleep for at least. It doesn't say sleep for exactly. So there's a bunch of semantic problems which work when you're programming normal programs, but don't work when you're making music so much. And so I wanted to build a system where Ruby could send a message to something else, which could then schedule it at the right time. I wanted that something else not to have a garbage collector. I wanted it to have really well-defined timing semantics. And so the only thing I could think of was, in Ruby, the way I would implement it, if Ruby had good timing semantics, was wait for a message to come in, look at the timestamp, spawn a thread, wait for the difference between the current time and the timestamp, and then forward the message on. But of course, as I said before, you got timing issues with the way Ruby is implemented. But Erlang does that beautifully. So it's designed for exactly that thing. So spawning threads is no time. There is no global garbage collector. Each thread has its own isolated memory. It's got a very beautiful design for a very, very low latency, highly concurrent operations. And so it was exactly the right architecture. Then my problem then was how do I sit down and spend the time to learn Erlang? But actually the easiest way to write Erlang programs is to go and make friends with one of the co-creators, Joe Armstrong, which is what I did. And he's a lovely chap, really nice and super interested in Sonic Pi. And it's also interesting to see that a lot of the design in Sonic Pi is basically a really half-assed implementation of broken parts of Erlang. There's a lot of symmetry there. But yeah, he wrote the scheduler, which basically receives a message, parks it for the right amount of time, and forwards it on. And so then, in addition to that, we also have another program written by another collaborator, Louis Lorette, which takes these messages and converts them to actual MIDI messages. That's a very high-performance C++ program. So there are a few other components, and these are all separate processes, all talking over the network with each other. So one can go down, but it doesn't bring the rest of the system down. And they can all be implemented in different languages to suit exactly the task they're doing. So the system which is shunting open sound control messages from a network to MIDI messages just needs to be a very simple C++ program. With this, you can go as fast as you can just take the bits from one bit and shove them to the other bits. Whereas the interface that wants to have a nice expressive language, Ruby is a really good choice for that. But it's not necessarily a good choice for the high performance data shunting stuff or the very well timed schedule. If that makes any sense.
Yeah, absolutely. Have you had any requests or considered making this an online application, like a web-based application?
I've got requests for everything.
I'll bet you do.
That's something I've been thinking about for a very long time. There's fundamental problems. So that the web audio is not yet as solid as this SuperCollider synthesis engine, which is fab. And so you'd have to really, to have something that's equivalently powerful, you'd have to have a really decent implementation of something like SuperCollider in web audio, which is rock solid. So there's a reason why most of if not all of the large music application, studio application software still doesn't use the web yet, because it's not quite there. Although I think there's been great strides recently. At this point, then you're talking about a whole entire rewrite.
Right.
You can take the ideas, but you can. So I have been working on a cloud version of Sonic Pi where you can run Sonic Pi in a remote server. And then, in fact, Googler actually implemented a prototype of this. And so you'd already have a browser editor instead of this Qt editor, which works the same way. But instead of sending because each process can run on a different machine, so the GUI can run on a different machine than the Ruby process, which can run on a different machine to the SuperCloud audio synthesis engine. So you can actually have a fully distributed system if you want. So you could totally have, and it's what we built, a cloud server running the Sonic Pi server and SuperCollider and connect it to a browser, and then the browser would send the code to run, and the server will then ship the audio back. And that works really nicely, but there's currently quite a large latency, so you've got to encode and decode the audio and ship it across the network. So there's a limitation there in terms of latency, how long it takes for your sound to be heard, but it's also possible.
That's really cool.
Is your job search stuck? Maybe you're not getting any interviews with employers, or maybe you are, but no job offers. Or you may be new and not even know where to start. This is Charles Max Wood, and I'm releasing a new course and ebook on how to find a job as a software developer. The course walks you through the process of finding the types of companies you want to work for, getting their attention, and putting your best foot forward as the candidate they want. I've coached dozens of developers in looking for jobs and have been able to help several people find jobs within 2 weeks to 2 months. So whether you're new to development, can't find a great job that fits what you want, or are looking for remote work from an area without a strong tech community, I can help. Go to getacoderjob.com and sign up today.
So can you talk to the DSL that you're using on Sonic Pi?
Yeah. What would you like to know about it?
What was your inspiration for creating your own DSL versus having a more graphical interface where people, when I think of the Raspberry Pis, I think of like that Scratch programming language?
Yes. Yeah, absolutely. We could talk about block-based programming, which is what Scratch is, because I have a huge admiration for it. I mean, in many ways, it's a visual Lisp, and it has all the advantages of that and more as well, because your syntax is a data structure which each node can have a UUID, which is a really powerful thing. So once you have each node having a UUID, you can move them around. You can see where the code has moved to. Whereas currently we're using these ridiculous text buffers, and you're entering commands like delete and insert a character, which are just completely nothing to do with the code, but everything to do with just writing ASCII text predominantly, or whatever encoding you're using. And so actually working with the data structure directly is a much more powerful thing. You can totally imagine edits as tree transformations rather than as insertions and deletions from a matrix buffer. So there's lots of benefits there. But why was Sonic Pi written? How was a DSL designed? Well, the goal really was to write something that could help kids engage in programming. Scratch did exist in these block-based languages, and the UK curriculum talked specifically about text-based languages in addition to block-based languages. Although, to my mind, as a computer scientist, I don't see a difference at all. And in fact, as I said before, I see many benefits of using a block-based language over a text-based language. So focus was on a text language. I had a very short amount of time, so therefore it was Ruby. And my background, my Ph.D. and the work I'd done in industry were all based on DSLs and in Ruby as well. So it was a complete no-brainer to me to do that. And Ruby is a great language for writing internal DSLs that have. But I mean, it has to match the kind of structures that Ruby can represent. And yeah, as I said before, you've got sequential programming and you've got these sort of lexical closures. And if you can model your ideas into those sort of two things, then Ruby takes you a very long way.
So I've seen you've been working on this since 2013.
Yeah.
And is it primarily you as the developer? When I looked at the insights, it showed you as pretty much doing the majority of the code.
Yes, I mean, so I created the project, I'm leading it, I do the majority of the work. As I said before earlier, we do have it's an open source project, and we have a fabulous bunch of people who have contributed in a variety of different ways. So we've got a core team of developers who are sort of the principal contributors currently, and there's evolving change there as well. But it's lovely to see people really sort of owning the work they've done. So, for example, the MIDI stuff I described. I mean, we have the Erlang stuff by Joe, but also Louis Lorette. He's a part of the core team, and he implemented all of the C++ MIDI to open sound control and vice versa stuff. So he can sort of own that project and maintain it himself. We have other contributions, which are how to translate Sonic Pi into many different languages. We've got synthesizer contributions. We've got visual contributions in terms of lights and dark modes. There's lots of people are contributing in a variety of different ways. And so you should definitely check out the contributors page on the website to see who's helped out. It's fab. But yeah, the majority of the work and mostly all the crappy jobs have been done by me. Yeah.
Right, as the core maintainer. So let me ask you this. You've put so much time into this, and this is not, I mean, you don't get paid for this, right? Or is this a business that you're running, or how do you justify the continued work on this?
That's a good question. Up till even now, actually, still, I am paid to do this. So I've been extremely fortunate to have had a variety of different organizations fund the work I've been doing. So initially, that first 3 months, I was funded by the Broadcom Foundation, which is the company which makes the chips that go into the Raspberry Pi. And then for the next good few years, the Raspberry Pi Foundation itself directly funded Sonic Pi, which is fab. And they really were great in the sense that they allowed me the freedom to develop Sonic Pi in the way that it is turned into. So that sort of freedom and that lack of specific control and direction really allow me to build what you see and what we can play with. And then since then, with a PiTop, which is an organization which make fabulous computers which have Raspberry Pis inside them, they provided some funding. The Arts Council England have provided some funding. So a variety of different institutions have helped out. We've had donors who are also emailing with financial support. I have a Patreon page which is growing all the time, which is fab. It's nowhere near enough to sort of support me on its own, but it's a fabulous starting point. And the goal now, as all this sort of funding is drawing to an end, is to figure out how I can continue to work on it, if I can continue to work on it, whilst also somehow bringing the money in to support it. So there is a shift between having been in a lovely position of having had the funding to having to find it myself. So I think Patreon is going to be a core part of this. I'm also starting to do much more gigs and performances and keynotes and workshops. So companies are hiring me now to come in and deliver a live coding workshop, and I can come and also give a performance and get everyone coding and observing what's going on. And this is great because it's not just because the system was designed to teach children how to code. I can deliver these coding workshops, like live coding workshops, to non-programmers, and that's a really beautiful thing to see. So see if I can get revenue from there on this Patreon thing, and figuring out, and maybe donations, figuring out if I can find a way to forge through, because I really do see so much opportunity going forwards for Sonic Pi. Like there was a bus from Finland which drove to Africa and taught 2,000 African women how to code with Sonic Pi. And wouldn't it be beautiful if we can get those people and their friends or their children to collaborate musically? So African kids making music with American kids, making music with Finnish kids all together. That would be a beautiful thing. And the language is there. It's just that we need the tools to link these people and to share their musical ideas with each other. And I think it could be a very beautiful thing to see.
Yeah, that actually sounds amazing. I don't know if you know this or not, but I run a company called Code Fund, which is focused on bringing money to open source projects through ethical advertising. I'd like to talk to you about that offline, but there are a bunch of different ways that people can generate revenue for open source. And I find that such a fascinating topic because there's so many organizations that are really trying hard to make it so that we can all continue to have our open source sustainable.
Yes, that's the critical thing. And if you look at the GitHub thing, that the last year there have been very few commits on Sonic Pi from me, really, because I've spent all my time figuring out how to make the what I'm doing sustainable going forward. And it's been beautiful for me to learn. It's been a fabulous learning opportunity, but it might not be using my skills to the best of their abilities. I mean, Sonic Pi is stalled in many ways, at least slowed down. So if I can figure a way to be sustainable in a way that I'm comfortable, that I'm not worried about whether I can feed my kids, then I think I can then use my mind more effectively to continue to develop Sonic Pi and make it better than it currently is.
Oh, absolutely. So where can people go to donate to your project via Patreon?
Well, the first thing I would ask is to play with Sonic Pi. So go to sonic-pi.net and have a play. If you don't like it, then definitely don't donate. But if it makes you smile and you think that there's value in this, either both for yourselves and for your friends and for children, then please, there's a Patreon site, patreon.com/Sam Aaron, SAMAARON. and then you can then join in support there. That'd be amazing. And if you could give me the equivalent of a couple of coffees a year, that would be great. Because I'd much rather have donations, small donations from a large number of people than large donations from a small number of people. It's much more sustainable and feels much more safe to me to allow me not to worry about feeding my kids.
Yeah, I understand completely.
Yeah. Yeah, I mean, it's when you have funding and it can just be removed in one sweep. It can be it's a very difficult thing to deal with and to plan for and to manage. And so having it so that it'll take a long time, hopefully, to get to that. Well, not hopefully, but it's looking like it's taking a slow increase of the patron support, which hopefully should mean it will be a slow decrease if interest dwindles rather than an immediate off.
And it looks like you got a pretty active community on Discourse. Yes,
absolutely. It's brilliant. And it's fabulous to see that it's not just because a lot of these music software, especially programming music communities, are very much programmer oriented and programmer focused. And that can come with a certain kind of way of being and talking and acting. And it's not the kind of, not always the environments I'm happy with. I mean, I struggle with environments where you ask questions and people say, well, that's a bad question. And you see that a lot in most programming circles. And so the nice thing about the Sonic Pi Forum is it's not like that, because we haven't just got programmers with that mentality. We've got artists in there. We've got educators in there. We've got educators from young to old. We have musicians in there as well. So it's beautiful to see all these people using programming as a medium to communicate and share ideas with each other. And it's just really lovely to see. So, for example, we have an educator from the States who's been spent the last year teaching Sonic Pi in his music lessons. And he's been able to collaborate and talk to other programmers for ideas about how to implement things or how to change things or how to explain things. And to just have that crossover is just it's a beautiful thing.
One of the things I like in the forum is that people can post their music, and they're not posting like audio files, they're actually posting code.
Absolutely. So this is such a huge win for writing music with code. I mean, there's lots of negatives, right? It's weird and it's difficult perhaps and obtuse. But if you can represent your music as some weird syntax that can be stored somewhere, like dots and lines, like Western notation, then you have a huge advantage. And when Western notation was invented, the original musical score that allowed people to take a melody and then put it on a piece of paper and then put it on a horse and cart and travel across Europe and then have someone else read it and then turn it back into music. And you combine that with the invention of the printing press, we had this massive distribution of music that was just amazing to see. Well, I wasn't there, but I'm sure it was. And so that we have the same now, but not just for what the clarinet should play, or what the violin should play, or what the trumpet should play, but we have it for what the synthesizer should do through time, and what studio effects to add, and what randomization to apply. I mean, we haven't talked about this, but in Sonic Pi, I have a principle that the same code should always produce the same sound, and that's even if you're using randomization. Even if you're using multiple threads, which are race conditioning with each other. If those things are all resolved, then it's all completely deterministic, which means that I can take my piece of code and send it to you, and you can hear exactly the same things that I heard. And this then opens up so much opportunity, because now we start to collaborate over sophisticated music by reading each other's musical ideas. But it means also that when you go and see performances, where people are writing this kind of code live, it's like live coding performances, often you'll see people projecting the code that they're writing whilst they're performing, which is kind of like going on stage with a guitar and showing the audience your guitar. It's a revolutionary thing. And when you go to see a guitar concert, you totally see the guitars on the stage. But when you go to most electronic artist performances, you rarely see what they're actually doing. I think that live coding opens up this in a fabulous new way, which allows the audiences not just to see that the performers constructing the music live, but also if they have had prior training or observation of the system that they're reading, they can start to see what's going on. They can understand how the music was made, which means that if you go to a gig you really like, ideally you should be able to go home and recreate it at home yourself, and then modify it and mash it up and turn it into something new, add your own spin on it. And if the ingredients to the sound, if the ingredients to the music are open source, if they're something that's text you can email and transfer as a gist, then that's totally an option. Which also then means that in 100 years' time or 1,000 years' time, the music that we're composing in code can still be interpreted and understood in the future.
That's really cool. It reminds me of a modern chord chart or something.
Can you explain?
So what's the future of Sonic Pi look like? What kind of features or things do you have on the roadmap?
So the primary thing is figuring out whether I can sustain development going forward. So that's it's like a business problem rather than a technical problem. And if I can sort that out, there's a bunch of interesting things I'd like to work on. At the moment, I'm working on accessibility. So I want to make sure that more people can use Sonic Pi than currently can. So I'm working on making sure the screen reader software works well, adding a high contrast mode, and adding navigation hierarchy that screen readers can work through and work with. And so accessibility is a big thing. And then also just collaboration in general. So that the ability for people to share and coordinate their compositions, their distributed concurrent compositions. That sounds crazy. That's just like two programmers that aren't co-located working together using Git. So it's, for programming, all these things are rocket science. But applying them to music, it just opens some new opportunities. So can we get children from Africa composing music with children from America? Can we also get children from Africa performing music simultaneously with children in America? So using the internet and streaming the events, not the audio, but the events that create the audio, and having their individual systems either end turn those events into audio. It's totally feasible and exciting. And then also being able to co-locate performances. So in the same way you might have a rock band with 3 guitars, there's no reason why you can't have a rock band with 3 laptops linked together with a network and then using those to jam together. So these things they're all possible at the moment, but they're not super simple and smooth, and there's no supported sort of tutorial or framework to do it. And so a website to share these things. So these things I need to work on. And I've got lots of plans to make this a reality.
That's really cool. Well, is there anything else that we should know about Sonic Pi or any other interesting things?
I mean, yeah, so I don't know, it depends. I need to ask each individual person listening to this what they're interested in and try and go back and find and answer it. I mean, what's important to realize is that this whole coding music thing is a whole brand new thing, and we're still very much in the early dark ages. And if you look at a guitar, that guitar's had thousands of years of evolution, of design evolution, to turn it from the object it once was to the object it is now. And we haven't yet had that for programming languages in general, but certainly not for live coding systems. So we're still very much at the early stages. But even what we have right now is really exciting in terms of its potential. And so we really should start seeing these things as new instruments, new musical instruments, and exploring them in those rights. And I think it's really tough for me to come across people who say that code can't make music, or code is rigid in structure, and of course we realize that we can have randomization, we can have abstractions, we can get the computers to make mistakes. It doesn't have, we can interpret things differently each time. We don't have to be deterministic if we don't want to. It's easy to turn deterministic into a non-deterministic one. So there's lots of opportunities. So just to invite people to have a play, not to have any preconceived ideas, and then also to realize that if you hear someone making music with Sonic Pi and you don't like the music, you can totally make other kinds of music. You don't always have to make the same kind of like dance music that I'm making, which is a bit sort of contrived in many ways, but it is easy to make because the loops are simple to write. But there's a whole range of different sounds you can make, so really just to explore it. And if people do play with it, which I hope they do, to really start to share their work with others so that other people can learn, and to realize that this idea that we're not musicians is just complete claptrap. We're not all professional musicians, is a fairer statement. So just not worry about what things sound like, just to experiment, just to play. And once you've done it, just to share with others, because you don't know. The problem is that you find is that people might be too reluctant to share their musical compositions with us because they think it's not very good, because they're comparing it to the professional music that they buy and they adore. And actually people don't realize that the work that they think maybe not very exciting could be really inspirational to other people. So trying to get people to share their work with us, even though they think it's not very good, because they've got no idea who it might inspire and touch. And even if it's not musically, just like the code structures might inspire people to write something exciting with the same code structures. I think that's something I'd like to get more people doing. So share your work with others and celebrate the beauty that code is not just for business. It's something we use to express our ideas as humans.
So I think to wrap this up, I do want to share one more pretty amazing song that I found out there, and it was just a quick little Google. But so this is written, and there's a whole bunch of comments in it, but this whole song is 206 lines of code. It's the Mario theme song.
Ah, yes, that was
so. Yeah. Yeah, it's actually dead on. I could hear the whole thing. So, yeah, we'll link it in the show notes. But when you listen to this podcast, make sure you download Sonic Pi. You grab that song from this gist that I shared on here, and it's pretty fantastic. I was surprised.
That's Xavier Riley wrote that. It's fabulous.
Yeah.
I'll see if I can get that to play.
Perfect. All right. Well, it's been great having you on. I'm fascinated by this. I do remember watching somebody present, I believe, on Sonic Pi probably, man, it must have been 5 years ago at a Ruby group. And it was pretty neat to see this come around full circle and that it's still up and going. The part that I find interesting is that what you have here is an intro and outro music generator for podcasts. You know what I mean?
If you want to do that, I saw you can make ringtones with it. Yeah.
Yeah, that's incredible. It's incredible.
Although someone did send me, now a close friend, 2 records produced with Sonic Pi. So it's not just about intros and outros. People are actually making someone made an opera in Sonic Pi.
So how can we find these? Are they linked on Sonic Pi website, or how can we find out?
Yes, I only know about them through Twitter, and I retweet these things.
Okay.
So I'm trying to bring them into the community forums. But any ideas about how to make these things a bit more easy to find? I mean, the really big, exciting things go on the main webpage. So, for example, like next year, ridiculous thing is I'm playing at the Royal Albert Hall with Sonic Pi in the UK, and 3 years ago I got into the Rolling Stone magazine. Playing code in a music festival.
Oh, wow.
So, those kind of things are on the website. But yes, I think more community things. This is what we need. We need to build a really nice place to share these ideas and these works. So to be able to go to a website and download an opera and download a rock song and download a dance track, it'll be wicked. And then see how they're made and then be able to make your own.
Yeah, I got it queued up, Eric.
Let's hear it. And that's it.
All right, I'm going to stop playing that before the wife thinks I'm just playing video games.
Okay.
Well, Sam, if people want to find out where you're at and what you're working on, where can they go? Or if they want to learn more about Sonic Pi?
Just go to the website, it's the best place, and the forum in-thread.sonic-pi.net is the place to go and chat about things. You can follow me on Twitter, Sam Aaron, and Instagram as well. I'm sort of posting pictures of what I'm doing there. But yeah, if you've got questions and you want to discuss things, the forum is absolutely the best place to go. If you want to get started, the tutorial is the best place. That's both inside the application itself. There's a full book inside the app that's translated to many languages, but also that the English version of the tutorial is also on the website, which makes it much more convenient to work with. And if you've got screen readers, these can read the tutorial as well. So the website and the forums are the best place, and then Twitter and Instagram if you want to follow what I'm doing. And if you want to hire me to come and give you a performance or a workshop, then please let me know. It's a lot of fun, especially if you get your bosses making crazy dance music. It's huge fun. Yeah.
Well, awesome. Well, should we move on to picks?
Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
All right. So my pick is going to be kind of a two-part pick. One is SimpleCov, and it's a way where you can run on your application, on a Rails or Ruby application, to see if you have test coverage. So it'll show you where you're missing gaps on these specific controllers or models, where you're missing coverage. And then as you're developing on, let's say if you have pretty high code coverage, 80% or higher, but then you realize that you implemented a couple of new features or a couple of new bug fixes, and you don't know if you had enough code coverage on those yet. So there's another gem called Undercover, which will show you the gap in code coverage between your last commit. So before you commit up your changes to GitHub or whatever code repository you're using, you can see if you have code coverage on the new things that you've just committed. So it's a way that you can kind of keep yourself in check on ensuring that you're not dropping your code coverage, but you're maintaining or increasing it.
All right, so I do have mine now. So what I've been wanting to get really, really bad is the Artiphone, ARTIPHON. And I think they started off as a Kickstarter, but what it is, it's a MIDI device that looks like a guitar/piano. It's like a mix between it, and the type of music that you can generate through this thing is pretty amazing. So it's you can find it at I think just artiphone.com, but and I don't even know if that's how you pronounce it, but yeah, it's pretty neat.
All right. And Sam, do you have any picks?
Good question. Yeah, I mean, picks. Best pick is a really fabulous program for making programs. It's called Emacs. And it's just a fabulous environment. You get to write text in a beautiful way, and you can extend it using this beautiful language called Lisp. So I definitely recommend, if you haven't heard of it, it's Emacs programming editor, and to just whittle your life away with it, and it will become your new hands.
Yeah, I think Chuck is a big Emacs person, so good thing he's not on this podcast.
So I'm just here.
All right.
It's hard to come with good picks.
All right, Sam. Well, I really appreciate you coming on today. A lot of interesting over my head topics, but it was really interesting and cool.
Cool. And I'm sorry if it went over your head. If you're obviously able to, on the internet, ask me any questions and I'll try my best to make sure it's not. Because the whole goal of what I'm trying to do is to make sure it's not something which goes over people's heads, but something that if they spend the time to learn, it is something they can learn.
Yeah. You're also talking to a guy here who got just the sympathy clap from doing karaoke. So I'm going to reiterate my not very musically talented.
Yes.
Yeah.
Things can change.
Yeah. Well, cool. Well, thanks again for being on the show today.
Thank you very much for having me. It's been a real pleasure and delight. Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.